As was mentioned, we'll be talking a little bit about LLMOps, a little bit about MLOps, Airflow 3, and how that's beneficial to this kind of use case, and the Airflow AI SDK. So a little bit about me. I'm Ryan Hatter. I work at Astronomer. I'm a sales engineer here. I spent the majority of my 3.5 years or so here leading the Airflow support team, which was actually kind of the inspiration for what turned out to be a hackathon project, a blog, and now this talk. I love Airflow. I've been doing it for 5 or 6 years, contributing for about as long. Some point last year, I was also became an Airflow committer. So Airflow, big part of my life, probably a big part of everyone's life here. I'm also an LLM skeptic. I don't know why I'm talking about LLMs here. But ultimately, I think there are there is a time and a place for LLMs, even in production use cases. So yeah, we'll introduce the problem, kind of what I'm trying to solve with an LLM, and talk about Airflow 3 and how that enables better MLOps, kind of beyond just LLMs. We'll focus mostly on LLMs, but Airflow 3 has a lot of new features that are quite beneficial to kind of machine learning pipelines. Airflow AI SDK, some additional challenges to the project beyond just like question and answer, and then we'll talk about the takeaways and do a little bit of Q&A. So the problem. So like I said, I led the Airflow support team for a couple of years, and one of my mandates was how do we grow the capabilities of the support team without growing the headcount of the support team? So Astronomer, high growth company, we have new customers every day, and so it's really there are new problems. So there's more work to be done, but we can't scale linearly the headcount because that's not really sustainable. So what do we do? I remember the first time I asked ChatGPT to write me a DAG, like ChatGPT 3, and I was like, oh my God, I'm going to get fired in no time. Obviously, that didn't happen. And I think like the idea here is not so much to replace support, but rather augment them, give them insights, right? Faster MTTR, things like that. And so ultimately, the idea was to identify similar tickets that have been solved in the past, right? Because the support team will have, maybe 6 months ago, I solved problem X for customer A. Then, problem X happens again for customer B, and someone else is looking at the ticket. Now they have to go and solve it, but I've already solved it. So, it's duplicate effort. It's a waste of time. And so LLMs, I think, are kind of a natural fit for this kind of use case, and specifically with RAG. And we'll get more into that in a second. So here's an example of such a problem. Is anyone not familiar with the term zombie or heartbeat timeout in Airflow? Okay, so everyone has had their tasks killed because some competitive task consumed a bunch of memory, caused the Airflow worker to run out of memory, and then kill all of the tasks running on it, right? So super common problem. And if you have been around Airflow long enough, you'll quickly understand that chances are high that one of your tasks caused everything to run out of memory. Maybe a collection of all the tasks on a celery worker caused everything to run out of memory and ultimately go down. SIG kill, -9, missing task logs. This happens all the time. So what if we have a new intern who has never seen this problem before? It'd be really handy if we could see, hey, this is probably a resource issue. Maybe it was at CPU utilization for 100% for long enough for Kubernetes to kill it because it surpassed the liveness probe. Maybe it's memory, whatever. It'd be nice to kind of have that validation. And of course, there are whole other classes of problems that aren't so trivial, that aren't so maybe so obvious, right? And so the idea is to ask an LLM, say, hey, find a related ticket, summarize the problem, summarize the solution, and then surface that in an internal comment. Because even if you have a really, really good LLM, they still hallucinate. And it's a bad look when you have some kind of automated response that is incorrect. Like, that's just kind of embarrassing, and you'll lose credibility, right? So the idea is to post an internal comment, which is this yellow thing here. Just go ahead and update resources, right? No one wants to hear it, but it's often the problem. And so the idea was to allow support engineers to, respond to tickets faster, get a head start, not solve the same problem over and over again. And taking a step back, so all of this is, of course, possible in Airflow 2. It's just a little clunkier, right? So there are several new features, pretty key features in Airflow 3 that just make your lives a lot easier when developing these kinds of workflows. So event-driven scheduling. in Airflow 2, to do something like this, you would have to have a long-running DAG that has a sensor that's waiting for something. Of course, you can defer it, but still, it's just kind of weird to have this long-running DAG. Or in the ticketing system, you'd have to implement some kind of webhook that when a new ticket is raised, you have to go ahead and send some kind of API post request to trigger a DAG run, blah, blah, blah. With event-driven scheduling, you can just have this kind of work automatically. Actually, when I built this project, this wasn't even possible. So the only, I think, event-driven scheduling trigger was for Kafka or SQS, I think. As a result of this, I worked with one of my colleagues, Karen Berganza, who built the HTTP event trigger that allows you to do event-driven scheduling based on HTTP requests. Also backfills. So in Airflow 2, backfills are super clunky. They ran like a separate process from the scheduler, which causes all sorts of weird things. Wouldn't necessarily respect things like pools, concurrency, whatever. And so you can really kind of overwhelm, third-party APIs, things like that. Airflow 3 also has improved inference support, so you don't have the necessity to have a unique DAG run for every single, a unique run ID for every single DAG run, so that causes challenges with things like experimentation. And there's a lot more coming, or has come in 3.1 if you saw any of the things around the human in the loop operator. So beneficial for things like reinforcement learning, and there are applications beyond machine learning. There's also the ability to get a response from a DAG, like trigger DAG run API that's not just like a 200, hey, your DAG kicked off. You can also get results from a DAG run, which helps you do it with inference. So the Airflow AI SDK, and again, like this is certainly possible without the Airflow AI SDK. It's just, this makes it a lot easier, more Pythonic, allows you to write much cleaner DAGs. So you see here, you have the task.llm decorator, which allows you to pass in some kind of a model that you want to use. And it just makes it a lot less boilerplate, a lot cleaner, and a lot easier to do, again, clean Pythonic DAGs. Also, one more note on this. The Airflow AI SDK is essentially, for the most part, a wraparound Pydantic AI. So if you're familiar with that, this is mostly just kind of a wrapper around that, and there's also some additional functionality that we'll get to in a sec. So this isn't strictly part of the Airflow AI SDK, but it is related. As an astronomer doesn't want to be sending our customer data to, from our ticketing system out to OpenAI, Anthropic, whatever. So the idea here is to run local inference, right? So we want to have a model running on an Airflow worker that is capable of, producing some kind of output or some kind of result that we can then use. And so what we have here is the ability to run Ollama on a Celery worker so that we can use open source models and run inference, without our data ever leaving Astronomer's environment. So some of the additional functionality beyond like the Pydantic AI wrapper stuff. So part of this, I contributed the task.embed decorator to the Airflow AI SDK, and this allows you to vectorize text so that you can more easily perform RAG operations. So RAG is a retrieval augmented generation. We don't have GPUs at Astronomer, so we can't train our own model specific to Airflow. That would be massively costly, waste of money. But we can use RAG. So we can take, we can, at runtime, we can search for data that we've seen in the past, capture that information, and then use that to kind of augment the LLM, so it's specific to Astronomer data. So our ticket data, our knowledge base, things like that. So you can use task.embed to vectorize your data and then ship it off to some kind of vector database. And so it's kind of helpful to see this instead of just kind of talking at you. The purple outlined things here are related to Airflow 3. The blue-green are related to the Airflow AI SDK, or just kind of AI in general. So going from left to right, the first DAG, the backfill, the embed historical ticket data DAG, the idea here is to take all of the data that we're storing in, in our data warehouse, all of the ticket data that we have previously, vectorize it, and then store it in a vector DB. And backfills in Airflow 3 make this a lot easier than it otherwise would have been in Airflow 2. We have the Ollama stuff, task.llm to summarize the tickets. So as we go and look at this historical data, we summarize it, because in a ticket thread, you're going to have a ton of like useless metadata that's just not relevant at all. So let's just go ahead, identify the problem, identify the solution, summarize that, and then ship it out to the vector DB for RAG search later. Then we have with get ticket ID over here, this is kind of the event-driven scheduling part. Again, as part of like this, the ability didn't exist yet, but now what this would be like is you have the HTTP event trigger that is kind of constantly polling the ticketing system for new updates, and then we can find any new tickets, take that information, summarize the information, vectorize it, and then search against our historical ticket data. And then finally, again, for the inference itself, we want to embed like I mentioned, we want to embed the new ticket data and then search against the vector DB, find the relevant tickets. Now, the first time I ran this, I was really excited. I was like, okay, this is going to be so kick-ass. This is going to be really cool. And so I ran inference for the first time, the whole pipeline, and I put in something along the lines of like, hey, missing task logs, sigkill -9, whatever. And the result that I got was something about, real estate. So it said something along the lines of like, hey, you can sell your house for 20% more than market. And I'm like, what the hell is going on? It turns out in the, like I built the search to search inverse. So it was the least similar tickets. And someone had sent some spam email to the Astronomer support email and resulted in, some quacky thing that is obviously completely unrelated to Airflow and everything about it. That made me kind of take a step back and kind of rethink what I should do here. Now, of course, I could have fixed that. I didn't realize until later that what I was doing was wrong. But anyway, I kind of changed tact here, and instead of having a summary, instead of risking kind of some kind of hallucination that maybe an engineer would rely on without kind of doing due diligence, I changed my philosophy to kind of say, hey, instead of doing that, let's find the call it 5 most tickets that are most similar to the one that's being raised, provide a link to that ticket, and then you can go investigate. And maybe it's not perfect, but it is still quite a bit faster. And I had big plans for this. I wanted to productionize it in my spare time, in any spare cycles that I had, but I got a little bit distracted. So I had little baby Zoe 7 weeks ago, went on paternity leave, and Astronomer took a bit of a different tact. We hired an actual machine learning professional, unlike some kind of hobbyist. And he decided to kind of take more traditional machine learning approaches like ticket similarity and use typical software engineering or historical machine learning tactics to go about this problem. With that being said, I do think like there was potential for this to kind of be useful in a real world scenario. And so some takeaways, yeah. Airflow is quite capable for certain inference use cases. Of course, like if you have some kind of streaming application where you need to, stream inference results in seconds, Airflow is not going to be the right tool for the job. But if you have like batch inference use cases, like something that we saw here, or I don't know, it doesn't have to be LLM related either. It could be any kind of ML batch inference. Airflow is quite well suited for it. But if you are doing LLM specific inference, the Airflow AI SDK is a really nice tool to kind of make that more Pythonic and make it more cleaner DAGs for your Airflow AI pipelines. And that's that. Last thing, the 2025 Airflow survey is live. If you could take a few minutes to fill this out, small contribution, but this is taken very seriously by the open source community. So if you want your voice to be heard, this is a great opportunity to do that. And thank you.